All right, you guys remember in geometry when you did proofs, how much you loved that? I'm sure nobody on the video can hear my entire class clapping and cheering right now. So it's not as bad as geometry proofs, but it is similar. We are going to have to show like every single step that we do. What we don't have to do is we don't have to put a reason. Okay. We just have to show every single step. So this is like a proof. It's like justifying your answer with work. So we're going to be doing, it's called verifying trigonometric identities, verifying. And you will be given an equation. This equation is not an equation you can solve. So here's some examples down here. You're going to be given an equation. This is not an equation that you can solve. These are all identities, meaning they are true for every single x in the real numbers. So we can't solve these. What we have to do is we have to prove that one side does equal the other by showing the steps to make it say the other side. That's what we're going to do. So example with number, it's not in number one. With example number one, what I would do is I would look at these two sides and I would say, I think I'm going to take the left side. I'm going to move some stuff around. I'm going to do some substitutions and I'm going to make the left side look like the right side. So what I do is I box in my right side because that's the side I'm trying to get. And I only work on my left side. So I'm going to try to keep my equal sign as kind of like a column separating the two sides. And above this, there's like 5 different things. These are guidelines of what we could try. So we are going to go over these guidelines as we need them. But for the very first guideline, work on only one side of the equation. It says at a time. That's like per question, not at a time, but like per question. And then it says it is often better to work with a more complicated side first. And more complicated besides with addition or subtraction. That actually makes it more complicated. There isn't a wrong side to work with. There's just one that's going to be much easier for you. And it's the one that looks more complicated to begin with. So what we're going to try to do is we're going to try to make secant squared x minus 1 over secant squared simplify to equal sine squared x. So you know how your assignment last time was simplified and what'd you get? This time I'm telling you, you're going to get sine squared x. Show me how you can get it. So there are lots of different things that we could do. And I can call on people in here and I will be calling on you for ideas, but I'm just going to start with mine just to start. There are lots of different ways that we could approach this. I'm going to approach this one by taking this secant squared x that's in the denominator, this one here, and that's like multiplying by 1 over secant squared x. It's the same thing. Instead of dividing by a number, I can multiply by its reciprocal. And then it becomes the distributive property. So I'm going to use the distributive property and I'm going to write my numerator secant squared x over my denominator, secant squared x, minus 1 over secant squared x. So I distributed that 1 over secant squared x to both terms in the numerator. So that is one step. Now I'm going to draw another equal sign because now I'm going to do something else. Secant squared x over secant squared x is 1. Minus 1 over secant squared x, it's cosine squared x. And now that I have 1 minus cosine squared x, I start thinking about those Pythagorean identities. And if you don't know those, gosh, my stylus stopped working. There we go. If you don't know those, we should at least know the first one, which is sine squared x plus cosine squared x equals 1. And if I make this equation into 1 minus cosine squared x, stylus not working again. There we go. If I change this equation around, so I move the cosine squared x to the other side, then I'm just going to have sine squared x. So you don't have to have all of those trigonometric identities memorized. You just have to know how to manipulate the first one. Now, this does match the original, so I'm done. So what you're doing is you're showing all the steps until it does equal the other side. This is what verifying an identity is. Verifying. Okay, now I'm going to go back up here into like suggestions because you're going to look at it and sometimes you just have no idea what to do. So you want to look for opportunities where you could maybe factor. Maybe if we have fractions, we could find a common denominator. Or look at substituting the identities, which you guys have been doing. Look at the other side to see what you're trying to get to. Don't just work with one side, but look at the other side and be like, okay, I need to get sine. How can I make this tangent turn into sine? Or whatever the question says. And then sometimes it just helps, not always, sometimes it just helps to convert everything into sine and cosine, because every single trigonometric ratio can be converted into a sine or a cosine. For example, what's cotangent? Cosine over sine. That's helpful, right, to know that? What is secant? 1 over cosine. So you could take every single one of them and convert them into sines and cosines. And sometimes that gives you an idea of what to do. Sometimes it does, sometimes it doesn't. The last thing is the hardest thing for my students always, because you guys are so afraid to make a mistake. But you have to know that if you make a mistake, you actually might learn something from your mistakes when you do these. When you will not learn anything is when you don't do anything. And this is how it's going to work in here. If you want help from me, there has to be work that you've tried something. You're going to come up to me and you're going to be like, I'm stuck. I don't know where to go from here. You cannot come up to me with the original question and say, I'm stuck. I don't know where to go from here. You have to try something. So again, you're going to look for maybe changing everything into sine and cosine. You're going to look for substitution. You're going to look for factoring. You're going to look for adding fractions or subtracting fractions. You're going to look for things like that. So now I am going to just guide you, but I'm going to look for suggestions from you all, and we're going to work through these together. The first thing you want to determine is which side should we work with? Which one looks more complicated? Left or right? Left. Then let's work with the left side. I'm going to box in the right side. Oh, as I'm taking notes today, I am doing these a specific way, not because like that's how I want to do it. This is how it is done. Remember in geometry when you had the 2-column proofs, like you had to do it that way. So don't do it your own way. Do it this way. Follow the form. Okay? If there's not enough space to write, you can always zoom in really far and write even smaller, which is what I'm going to do now because I tend to forget about how much space I have. You can even make the stroke smaller. Okay. Who has an idea? This video is going to be an hour and a half long because nobody's answering me. Who has an idea? We have to make, I'll call on you, John, but we have to make the left side look like the right side, and I see fractions on the left, no fractions on the right. I also see an addition sign between the fractions on the left. I see no addition sign on the right. These are things I have to get rid of. John, what's your idea? So when I created that box, I can't touch it. I can't do anything that goes to the other side. I can only do things to the left side. Anthony.
Could you do 1 minus secant x on the left, like to get rid of the
Very good question. Is the reciprocal, don't write it down, look at what I'm writing. Is the reciprocal of 1 over 1 minus cosine x, is the reciprocal of that, what did you say, 1 minus secant x? So let me make up an actual number and see if it works. Is the reciprocal of 1 over 1 minus 3 the same thing as 1 minus 1/3? So I made the reciprocal, because these are reciprocals here. So would those be the same answer? This one would be, oopsies. This one would be -1/2. Would this one be -1/2? No. They are not reciprocals when we have that extra subtraction. We have the extra term in there. It doesn't work that way. And you know what? I'm so glad you brought that up today, because there's so many people that will do that. And usually they don't bring it up in notes, and they just do it. And we don't get the opportunity to talk about why that's not a thing. Okay, different idea? Who's talking? I couldn't. Oh, Daniela or Caleb? Oh, I thought you were doing that. Daniela. We can find a common denominator and add our fractions together. That's what we need to do for this one. We need to find a common denominator. Another thing that students have trouble doing is finding that common denominator. So this is how I would approach finding the common denominator. I would look at 1 minus cosine x, which is a denominator right now. Can I factor anything out of 1 minus cosine x? Can I factor anything out? Besides the number 1, because 1 times 1 minus cosine x is the same thing. So factor anything out besides 1. Can I do any factoring here? Do you know what I mean by factoring? So what's the answer? Factor yes or no? The answer is no. Can I factor anything out of 1 plus cosine x? No. If you cannot factor anything, then finding the common denominator would be multiply them by each other. If you can't factor it, you got to multiply by each other. Just the same like if we had a 7 and a 5 down there. They have nothing in common, so we would have to multiply by each other. So I'm going to do this in color so you can see, but I will have 1 over 1 minus cosine x multiplied by 1 plus cosine x over 1 plus cosine x. And then I'll have 1 over 1 plus cosine x multiplied by 1 minus cosine x over 1 minus cosine x. And these parentheses are understood, but I'll put them in so we can actually see them. So on top, I will distribute, and I'll get 1 plus cosine x. On the bottom, we need to FOIL that together, multiply that together, which I didn't leave a ton of space for, but I guess I will just do it right here. Notice how my equal signs are lining up every single time. I'll zoom back in a second, but notice how my form is staying the same. Okay, once I have a common denominator, oh, by the way, the middle terms of that cancel out. Once I have a common denominator, then I can add my numerators. Over that common denominator. And then I can combine like terms in my numerator. When I combine like terms, my cosine x and the minus cosine x make 0. So I get 2 over 1 minus cosine squared x. I'm going to zoom out just a little bit. I always want to go back up and like remember, what am I trying to solve for again? But since I'm zoomed in so far, I can't see it at the same time. So if you see right now, I did get a 2. So I know I'm on the right track. How am I going to get cosecant x? So here's me using the other side, but not actually doing anything to the other side. I'm using it and saying, how am I going to get cosecant squared x when I have a 1 minus cosine squared x in it? Nick? Is sine squared x from those Pythagorean identities? Yep. Which then we can flip and get 2 cosecant squared x using the reciprocal identity. Okay, when I zoom it out really far, is it too far that we can't see what I wrote? Is it too far that we can't see what I wrote? I do have a ton of empty seats in here, by the way. You can definitely move up closer. So this is what verifying an identity looks like. I kind of like it. They're like little puzzles. If I'm too slow, because I am recording a video and I feel like I don't want to miss out on anything on the video because people watching it at home aren't here. If I'm too slow, you can work ahead of me. And if you get stuck on something, when I get to that, tune back in. But I'm going to keep going like you all need every single tiny little step. So I am on, I guess this is example 3 now. And I look at these two sides and I definitely say that the 1 should be boxed in because I don't know how I'm going to take a 1 and make it look like the other side. But I can definitely take the other side and make it look like a 1. Well, I hopefully can. I am looking at this and we have 2 terms. Terms are separated by minus signs. And I notice that both terms have cotangent squared x in it. So for this one, I am choosing to factor out a greatest common factor of cotangent squared x. And that leaves me with secant squared x minus 1. And now I'm going to stop giving hints and I'm going to ask for you all to help. Sarah Nold?
Secant squared x minus 1 is tangent squared.
Okay. Do you have that memorized?
Yeah.
Okay. If you do not have it memorized, you shouldn't be using it. And I can show you a different way to do it if you don't have it memorized. So that should be, tangent? Is that what you said? Okay. Somebody doesn't have all those memorized. So if we have cotangent times tangent, we can make cotangent 1 over tangent squared x. And then that would be 1. So then we would be done just that quick. Is there anyone in here that would like to see me work it out not using the secant squared x minus 1 because you don't have it memorized? Yes, okay. I thought somebody might want to see it. I'm going to move over this out of my way and then I'll do it underneath that. So I'm still going to do the first step. Let me just change the color, I guess. I'm going to still have that first step of factoring. And then if I don't have secant squared x minus 1 memorized, I might do something like I might do something like 1 over cosine squared x minus cosine squared x over cosine squared x. So does everybody know where I got 1 over cosine squared x from secant? Where did I get cosine squared x over cosine squared x? That equals 1, but why did I put it there? And why didn't I just write 1? So I have a common denominator, right? So then I would have 1 minus cosine squared x over cosine squared x. Actually, I think I'm going to change my cotangent just in this next step. And since I have a cotangent squared x on the bottom, and I know what my next step is going to be for the parenthesis here, I'm going to change cotangent at the same time. Caitlin, do you know what my next step is going to be for 1 minus cosine squared x? Right, that equals sine squared x. And since those are sines and cosines, I'm going to go ahead and change cotangent squared into cosine squared x over sine squared x. And then at this point, I think we can go ahead and say that's 1. So to me, it does not matter which method you choose. 1 was a little shorter, but then you have to know secant squared x minus 1 equals tangent. I for some reason can never remember which one's minus 1, which one's 1 minus, other than the original one. I can remember that one, but I guess I haven't taken the time to remember the others. So I usually just converted all the other stuff. Okay. So when I look at this next one, both sides have subtraction. I do not think one side is more complicated than the other. So I'm just going to ask you guys, which side do you want to box in? Actually, I do think there is one more side that's complicated than the other. The one that has cosine and sine is probably more complicated than the side that only has cosine in it. So if it were me, I would probably box that one in and work on the left side. But again, you could do this one either way. I have done it either way. What should we do? Kayla, give me a starting point. Okay, I'm going to interrupt him while he's thinking. This is where you can't be afraid to just try something. If you try it and it doesn't work, we erase it, we move on. You have to try something. Chris, you wanted to try something.
I was thinking, couldn't you
Yeah. No, but, well, you mean the minus sine squared x? Is what you mean? Yeah, so what we want to do, yes. So what we want to do is, looking at the right side, we only have cosines. The left side, I need to get rid of sine. But sine squared has a Pythagorean identity that says that sine squared is equal to 1 minus cosine squared. So once we convert sine squared into 1 minus cosine squared x, we've gotten rid of the sines. I don't know if that's what you were saying exactly, Chris. Is that what you were saying? So I'm going to distribute that negative sign. If you make a mistake distributing the negative sign, you're going to have the wrong thing. So we need to know how to distribute correctly. And then I've got a cosine squared x adding another cosine squared x, which is 2 cosine squared x minus 1, and then I'm done. So you just have to try something. You got to get your brain thinking, and then we can figure the rest of it out from there. Look at this next one. Which side should I work with? The right side or the left side? Which side is more complicated, the right side or the left side? Can't hear what you're saying. Left is more complicated? Why? Nah. More complicated will be, sorry, this is totally an opinion thing, I guess. But I will tell you, more complicated will be the ones that have, oh, it's a little bit further up, addition or subtraction. Those are the ones that are more complicated. So if it's the choice between addition, subtraction, or division, division's actually easier for these. So I am going to box in this side. Now, Nick, I challenge you to box in the other side, the thing you were yelling at me about. Box in the other side and try to get it. Because you can. Just trying to do it the easiest way possible. All right, so if we're working with the right side, we need to add those together. Sorry, subtract those. What should I do? Sarah Penny, tell me something I could do. Anything at all. Well, right now I don't have any denominators. Should I get a denominator? Cosecant? Change cosecant into 1 over sine x. Now we can find common denominators, right? So the common denominator would be sine x. So I would have 1 over sine x. And then this second one I'd have to multiply by sine x over sine x. Now we get sine squared x over sine x. All right, Sarah gave me the first step. Belle, could you tell me a next thing to do? And then what? Yes, 1 minus sine squared x is cosine squared x, yes. So now I'm like, what are we trying to get again? We're trying to get a secant and a tangent in a denominator. Are we getting close at all? I gotta fix my cosine. It's ugly. I couldn't handle it. Oh, it's still ugly. All right, what can we do next? We need to get a secant and a tangent in the denominator. Anthony.
Cosine squared x over 1 minus cosine x over sine x to get cosine x times
do you mean cosine x over 1 times cosine?
Yeah.
Okay. I think you said squared, but yes.
Yeah.
To do that, and then that'll give us cotangent. Oops. Okay. And if we have cosine x multiplied by cotangent x, then we can reciprocate both and get secant x, tangent x on the bottom. Done. Did you do yours? Your challenge?
Yeah.
Did you get it? Okay, I'll come see you in a little bit. I'm curious. Oh, did you get to cosine squared x and then change that to sine? 1 minus sine. I was just curious how you got the subtraction sign in there.
Well, yeah, I did it first, so I got.
You what?
I first got cosine squared x over sine x, then I changed it to 1 minus sine squared x.
Good. All right, the next example. Out of the two of these, which one looks more complicated? The left is more complicated. I mean, they look pretty identical, except for one has a higher power. What I'm actually going to do with this one, I'm going to tell you what to do with this one, is I'm going to factor, because on the left, I have a difference of squares. So from algebra 2, factoring a difference of squares, that's where we have 2 parentheses, 1 plus 1 minus. Cosine squared x in the first spots. Sine squared x in the second spot. That's how we factor that. All right, who can volunteer the next step? Connor. This one right here? We can, but that already matches this. So I don't want to go away from what I'm trying to get. So right now my energy is going to focus on this part here. Does it equal 1? Isn't that the identity you needed to memorize? Yeah. So 1 times cosine squared x minus sine squared x is cosine squared x minus sine squared x. And then we did it. Yay, that was a really short one. Was that the end? See, not too bad. So that assignment was actually posted on the last module because I didn't know how long we would take. And then I ended up just deciding to give you guys all that time. Oop, that's not it. That's not it. That's not it. Where's all my modules? That's not it. How did I lose this thing already? Here we go. It was posted on the last module. So your assignment is here. This assignment is going to go into the next class as well. So if you look at today's module, I've added 2 more on, but they're not all due next class. So you do have 3 worksheets that are due 2 classes from now, but you will have in time class to work on the second 2 worksheets. Does that make sense? So I'm posting them early, mainly because of so many people in and out, like crazy quarantine times. I'm posting things early. And then what you can also notice is that the 2 that were posted today say review. So what's going to happen in like 2 full classes from today? We will have a quiz. This quiz that we take on section 5.2 will be hand graded, because you guys are going to have different steps. It will be me looking at your steps and making sure that, yep, you did do everything correct. You do not want to waste time because today's assignment is a little bit longer. The other ones are shorter. This one's a bit on the long side, and you can't do it on here. You cannot do 26 questions on here. Okay, so that's where I was talking about in our modules, we have paper. If you go to the beginning of the modules, oops, I went to the home. I went to the wrong spot. In modules, we have paper, and towards the top, you'll see lined paper. Cami lined paper. It's 4 sheets of Cami lined paper if you're using Cami. And you just saw, you could zoom in as far as you need to. So that would be a good place. If you're just doing it on paper, then you can use as much paper as you want. But you guys have the rest of the class to work on this. And definitely ask me questions when you get stuck, or like what Anthony did earlier. If you weren't sure if you could do something, ask. I don't want you to practice things the wrong way. Okay? All right. Good job.